Hi everyone, and welcome to a video on the three Pythagorean identities. Alright, so we are going to get started here with our unit circle just as a reference over here on our right. But really what I want to pay attention to is our six trig functions, because we're going to reference this quite a bit. And we're going to start off with really just the sine and the cosine. And just a reminder, our six trig functions are sine, cosine, and tangent, and then their respective reciprocals, right? Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And just another reminder, tangent is the same thing as the sine over the cosine, okay? And just to show these very quickly, I just added these down below. So you can see sine of theta is equal to 1 over cosecant of theta, and vice versa. And you can see all of those six, okay? All right, so but let's go ahead and first start with sine, just sine and cosine, and we're going to develop our first Pythagorean identity. So let's go ahead and add up a little box here for us to write in our three Pythagorean identities, okay? All right, so step one here is going to be to just go over to our unit circle, and we are going to basically just create a triangle, and it doesn't really matter where it is on this unit circle, because what we're after here is, again, the x and y coordinates of some point on this triangle. So it doesn't really matter where it is. So I'm just going to create one right here, for example, and I'm going to go ahead and make this right triangle. We'll drop it down to the x-axis, and so there we go. So remember, our reference angle, all right, is always between the terminal side and the x-axis, and we have our right angle right there, okay? And so by definition, the unit circle has a radius of 1, which means no matter where I put this reference triangle, the hypotenuse is going to be 1. Also, as we learned from previous videos, the x value, right, the x value for this coordinate is the cosine of this reference angle. So we'll write cosine of theta. Okay, that's what the length of this side of this triangle is. It is literally the x value, right? And then the y value corresponds to the sine of theta, right? That's the height of this triangle, and that is the y value here. Again, doesn't matter where I draw this reference triangle on this particular, well, on any circle. That's always going to be true on the unit circle. Okay, so with this information, we are now going to go ahead and create our first Pythagorean identity, which is no real secret. We're going to use the Pythagorean theorem, right? A Pythagorean identity, and we're going to use the Pythagorean theorem to do it, okay? So what we're going to do is we're going to refer to this triangle, and again, this triangle could be anywhere, but the sides are always going to be the same, right? Hypotenuse is 1. One side is cosine, and the other side is sine of theta. So the Pythagorean theorem says that if we have a right triangle, if you take each side squared and add them together, each side square it and then add them together, then you should get the hypotenuse squared, right? So that the old formula a squared plus b squared is equal to c squared, right? So that means that if I took this side, sine of theta, then that would be sine squared theta. So I need to square it. So we write it. So the way we write this, by the way, sine of theta times the sine of theta. All right, we write it like this: sine squared of theta, because the square really goes with the sine. It's not really going with the angle inside, okay? All right, so let me just erase that, and let's go ahead and write this out now. All right, so one side squared would be the sine squared of theta, plus the other side squared, which is cosine. So cosine theta times cosine of theta is cosine squared of theta, is equal to the hypotenuse squared, which is just 1 squared, which is 1. And there you go. There's our first Pythagorean identity. All right, now let's go ahead and let's create the other two. And in order to do that, I'm going to erase some of our work over here just to make some room. And let's get rid of some of this. There we go. So now we have a lot of room to work with. Okay, so the one thing I want to mention here, because you're going to have to refer to this quite a bit, is since, let me just pick one of these. So since secant of theta is equal to 1 over cosine of theta, let's just pick that one out, right? And I just want to show you, what does the secant squared of theta equal? Well, secant squared of theta is equal to 1 over cosine times 1 over cosine, right? Secant times secant is equal to 1 over cosine times 1 over cosine. And so if I wrote 1 over cosine of theta times 1 over cosine of theta, then I would multiply across, getting 1 over cosine squared of theta. So in other words, the secant squared of theta is equal to 1 over cosine squared of theta. Okay, do you guys see how that works? All right, so using that information, let's go ahead and we're going to figure out our next identity. And can I erase this? Yes, there we go, without erasing everything else. Very good. All right, so let's go ahead and do that. So I'm going to go ahead and start with the Pythagorean identity, and that's where you always start, by the way. That's our base here. So the Pythagorean identity says sine squared of theta plus cosine squared of theta is equal to 1. And all I'm going to do, and actually to find both the other two identities, is first I'm going to divide by sine squared of theta, and then for the last one, I'm going to divide everything by the cosine squared of theta. Okay? So if I divide everything by sine squared of theta, we'll do that one first. That means I'm dividing this side by sine squared of theta and the other side by sine squared of theta, right? Because in algebra, whatever we do to one side, we have to do to the other. So I can break this up now, right? This is kind of like saying x plus y over z. Well, I could break this up to x over z plus y over z, right? This is going to be the exact same thing, the exact same idea. It's just that now we're dealing with these, instead of these variables, we're dealing with the name of these trig functions. So anyway, so let's break this up. So that means that the sine squared of theta divided by sine squared of theta plus, and over here I have cosine squared of theta divided by the sine squared of theta, just splitting those up, is equal to, and I'm going to keep the right side the same, 1 over the sine squared of theta. All right, and now we're going to go ahead and simplify this. So sine squared of theta over sine squared of theta, well, imagine if this was x squared over x squared. What would that be? Well, it's just something divided by itself, which is just 1. So that simplifies to 1. Plus cosine squared theta over sine squared theta. So I guess the first thing I'm going to ask is, what is cosine over sine? Well, cosine over sine is right here, which is cotangent, right? But in this case, it's cosine squared theta over sine squared of theta. So it's not just cotangent, it's cotangent squared of theta. So we'll write that, cotangent squared theta is equal to, and then 1 over sine squared theta, let's see here. Well, we know that over here, the cosecant of theta is equal to 1 over sine. So this is not 1 over sine, this is 1 over sine squared. So this must be cosecant squared theta. Okay, and there we go. We found our next identity from the Pythagorean identity, just dividing both sides by sine squared. So let's go ahead and write that out. So this means, and by the way, you can rearrange this if you want in any number of ways. I'm just going to leave it the way it is. So I'm going to say 1 plus the cotangent squared of theta is equal to, in this case, cosecant squared of theta. All right. Okay, let's erase this and let's figure out our third identity. There we go. And, oops, grab a different color there. All right, so the third identity is literally the exact same thing, except I'm going to take my Pythagorean identity and divide it by cosine squared of theta. So I'm going to divide both sides by cosine squared of theta. So I'm going to skip straight to the step where everything's divided by cosine squared of theta this time. Cosine squared of theta and cosine squared of theta. Dividing everything by cosine squared of theta, and now we simplify. Sine squared over cosine squared is, well, sine over cosine is tangent, and so this must be tangent squared theta. Plus cosine squared over itself is equal to 1. Is equal to 1 over cosine squared theta. Well, 1 over cosine is the secant over here. And so it's 1 over cosine squared theta. So that must be secant squared theta. And there we go. We have our third identity. So let's go ahead and write it down. So we have the tangent squared of theta plus 1 is equal to secant squared of theta. All right, and let's just go ahead and clean this up a little bit here. Get rid of all my work. There we go. Whoops. Accidentally remove too much. Okay, and so there we go. So these are our 3 Pythagorean identities, and we derive these simply from the Pythagorean theorem in conjunction with these trig functions, starting with just sine and cosine, really, but then kind of using all of them after that to get these different derivations of these identities. All right, there you go.